how to use technical vocabulary correctly, and how to communicate in a scientifically appropriate register. Numeracy across the curriculum. Chemistry is full of numeracy, units, formulae, ratios, percentages, graphs, calculations. You're not allowed to assume that pupils have learned numeracy in mathematics class and will simply transfer it. You must explicitly support numeracy in your chemistry lessons. When pupils calculate concentration, you are teaching numeracy. When pupils plot a graph of rate, you are teaching numeracy. Health and well-being across the curriculum. Every adult in a Scottish school is responsible for the well-being of pupils. That includes physical well-being in the laboratory, emotional well-being in your classroom culture, social well-being through respectful relationships, and mental well-being through how you manage stress and pressure around assessments. So please understand, students. Literacy, numeracy, and health and well-being are not optional add-ons. They are part of your professional duty as a Scottish chemistry teacher. The curriculum levels. Dear students, in the PGDE, learning is organised into curriculum levels rather than year groups. This is because pupils develop at different speeds, and CFE wanted to allow flexibility. The levels are early level, which is nursery and primary 1, first level, which is around primary 2 to primary 4, second level, which is around primary 5 to primary 7, third level, which is around S1 to S2, and fourth level, which is around S3. As a chemistry school, you will work mostly at third and fourth levels. So when you read the sciences, experiences, and outcomes, you will pay closest attention to the third and fourth level statements. After fourth level, pupils move into the senior phase, which is governed not by curriculum levels but by SQA qualifications, National 4, National 5, Higher, and Advanced Higher. So, curriculum levels stop at the end of the PGDE, the sciences, experiences, and outcomes. Dear students, now let us reach the very practical heart of today's lecture. The sciences, experiences, and outcomes, often shortened to sciences S and OS, are the statements that describe what pupils should experience and what they should be able to demonstrate at each curriculum level. They are written in the first person from the pupil's point of view, beginning with the words, I have, I can, or I am. Let me read you a typical chemistry-related experience and outcome from the materials organizer at third level. Listen carefully to the language. It says something like, through experimentation, I can identify indicators of chemical reactions having occurred. I can describe ways of controlling the rate of reactions and can relate my findings to the world around me. Notice three things, students. First, the statement is written from the pupil's perspective. Second, it combines knowledge with skill, knowing about reactions and being able to investigate them. Third, it gestures outward to the real world. That is the typical shape of every E and O. Each experience and outcome carries a code. The chemistry-relevant codes you will see most are SCN, which stands for sciences. After SCN comes a number indicating the level, 3 for third level, 4 for fourth level, and then a number identifying the specific outcome. So, a code like SCN 3 to 19A tells you it is a sciences experience and outcome at third level. You do not need to memorize these codes for life, but you need to know how to read them and how to find them in the curriculum document. Alongside the experiences and outcomes are the sciences benchmarks. The benchmarks were introduced later than the original ES and OS to provide more clarity to teachers about what successful achievement at each level actually looks like. The benchmarks describe specific knowledge, understanding, and skills that pupils should demonstrate. Where an experience and outcome might be quite broad, the corresponding benchmark gives you a clearer, more concrete picture.
So, in lesson planning, you use the experience and outcome to set the broad direction, and you use the benchmarks to make sure your lesson actually delivers the specific knowledge and skills that pupils need to demonstrate. Translating an experience and outcome into a chemistry lesson. Dear students, this is the moment where the theory becomes practice. Let me walk you through how to take a single experience and outcome and turn it into a chemistry lesson that you could teach tomorrow morning. Suppose your E and O is at third level and concerns indicators of chemical reactions and rates of reaction. Your first job as a teacher is to ask, what specific knowledge does this require? You read the related benchmarks. They might tell you that pupils should be able to identify a chemical reaction by signs such as color change, gas production, temperature change, or precipitate formation. They might tell you that pupils should investigate factors that change the rate of reaction, such as temperature, concentration, or surface area. Now you decide on a lesson. Let us say you choose to teach a single 50-minute lesson on the effect of surface area on the rate of reaction. Your learning intention flows directly from the E and O. You write something like, I am learning to investigate how surface area affects the rate of a chemical reaction. Notice the language, I am learning to, is the standard CFE form for a learning intention. Your success criteria are the specific things a pupil must demonstrate to know they have achieved the learning intention. You might write 3 success criteria. First, I can describe how surface area affects rate using collision theory ideas. Second, I can carry out a fair test investigation safely with marble chips and dilute hydrochloric acid. Third, I can plot a graph of mass loss against time and explain its shape. 3 measurable success criteria. The pupil knows exactly what they are aiming for. Your starter activity might be a short discussion. Show pupils a whole rock of marble and a small pile of marble chips. Ask, which would react faster with acid and why? Capture their initial thinking on mini whiteboards. Your main activity is the practical investigation. Pupils, in pairs, react to different particle sizes of marble with the same volume and concentration of dilute hydrochloric acid. They measure the loss of mass on a balance every 30 seconds for several minutes. They record the data in a results table. Your plenary brings them back together. They plot the graphs, compare results, and explain their findings using simple particle ideas. You explicitly link back to the success criteria. Pupils self-assess by thumb up, thumb sideways, or thumb down for each one. Now look at what you have just done, students. You have taken one experience and outcome, looked at the benchmarks, designed a focused learning intention, written measurable success criteria, included challenge and enjoyment, demonstrated breadth and depth, embedded literacy when pupils write their conclusion, embedded numeracy when they plot the graph, and embedded health and well-being through safe practical work. You have aligned with the 4 capacities by helping pupils become successful learners through the investigation, confident individuals through the safe experience, responsible citizens through fair teamwork, and effective contributors through the data analysis. That is curriculum-aligned chemistry teaching. That is what your university tutor wants to see. That is what your school mentor wants to see. That is what an HMIE inspector wants to see. Significant aspects of learning, profiling, and the PGDE to senior phase transition. Dear students, there are 3 more concepts I want you to understand before we close. The first is significant aspects of learning. These are the broad areas of learning within the sciences that pupils develop across the PGDE. They include things like inquiry and investigative skills, scientific analytical thinking skills, knowledge and understanding of the sciences, and the application of science to develop awareness of sustainability. As a chemistry teacher, you should be able to identify which significant aspects each of your lessons is developing. The second is profiling. At the end of P7 and at the end of S3, pupils produce a profile of their learning achievements across the PGDE. The profile is a summary that captures their progress and achievements. As a secondary chemistry teacher, you may contribute information about the pupil's S3 sciences progress that feeds into their S3 profile. The third is the PGDE to senior phase transition. The end of S3 is a critical decision point. Pupils select their senior phase subjects. Your role as a chemistry teacher is to give pupils, by the end of S3, a strong enough taste of chemistry that they can make an informed choice about whether to take National 5 Chemistry in S4. The S3 chemistry experience must be rich, challenging, and enjoyable, because that is when pupils decide whether chemistry is for them. National 5, Higher, and Advanced Higher Relevance. Dear students, you might be wondering, does today's lecture matter for SQA level teaching? The answer is yes, but in a slightly different way. CFE is the parent framework even for the senior phase. The 4 capacities, the 7 design principles, and the responsibilities of all teachers continue to apply when you teach National 5, Higher, and Advanced Higher Chemistry. So, at National 5, when you teach atomic structure, you still apply the design principles. You still embed literacy, numeracy, and health and well-being. You still work toward the 4 capacities. At Higher, when you teach Maxwell-Boltzmann distributions, the same principles apply. The pupil must still be challenged and engaged. The lesson must still show progression and depth. You must still address misconceptions in the pupil's wider development. At Advanced Higher, when you teach NMR spectroscopy or the Arrhenius equation, the 4 capacities still matter. Your pupil is becoming a successful learner through independent inquiry, a confident individual through tackling demanding content, a responsible citizen through ethical scientific practice, and an effective contributor through their project work. So please remember, students, CFE is not left behind when you enter the senior phase. It walks with you all the way to Advanced Higher. Common misconceptions and mistakes among PGDE students. Dear students, let me now warn you about the most common mistakes PGDE students make when working with Curriculum for Excellence, so that you can avoid them. The first mistake is treating CFE as a tick-box exercise. Some new teachers write a lesson plan, then at the end glue on a few CFE references to satisfy their tutor. That is exactly the wrong way around. CFE should be in the bones of your planning from the very start, not pasted on at the end. The second mistake is confusing learning intentions with activities. A learning intention describes what a pupil will learn. It is not what they will do. So, I am learning to investigate the effect of surface area on rate, is a learning intention. I am going to react marble chips with acid, is an activity. Make sure your learning intentions describe learning, not doing. The third mistake is writing vague success criteria. Success criteria must be specific and measurable. I can understand chemistry, is not a success criterion. I can plot a graph of mass against time and describe its shape, is a success criterion. Be precise. The fourth mistake is treating the 4 capacities as decoration. The capacities are not slogans. They are the actual purposes of education. Your lesson should genuinely build them. If a tutor asks you which capacity a particular activity is developing, you should be able to answer in a sentence. The fifth mistake is ignoring the benchmarks. Some students rely only on the broad S and O's and never look at the more detailed benchmarks. The benchmarks are where the precision lives. Always plan with both the E and O and the benchmarks side by side. The sixth mistake is forgetting the responsibilities of all teachers. PGDE chemistry students sometimes plan a lesson without explicitly addressing literacy, numeracy, or health and well-being. Always ask yourself, how is this lesson developing each of those 3? If you cannot answer, your plan needs more work.